Americans good at rabbits because they are वो blacks को देखा तो
ये बच्चे हाथ में जाए ना समझ अरे क्या अरे हटो हो गया 5 मिनट हो गया
Sounds good. Where did you start in the last class? You did almost long.
जापान में एक ही रहता है।
ये पढ़ते रहो, ये पढ़ते रहो।
So in the last lecture,
No, I didn't.
we discussed
I was absent.
Ohm's law. What is Ohm's law? You of this.
I was absent for 3 lectures.
I saw you in the last class. Anyone remembers what is Ohm's law?
Sir, V equals to R I. What is IR?
Both are same, right? So, can anybody explain what it means? What it means?
States that current flowing through the conductor is directly proportional to the applied potential difference across it, provided its temperature remains constant.
Yes. So, what does it mean?
It means that current which is flowing through a conductor.
It means that if the potential difference applied across the conductor, if you increase, then current will increase in the same proportion.
Yes.
Meaning, if you double the potential difference, current will also become double. This is what it means. Okay? So, and this will happen only when the temperature of the conductor remains constant. So, this you have to understand. So, graphically, what it means is, so if you have a circuit like this, to study Ohm's law, you require a circuit like this. Silence, everyone, pay attention here. So you will make a circuit like this to study Ohm's law. So when you increase the number of cells here, this V will increase. Okay? So in the voltmeter, you can measure the voltage. And you can measure the current in the ammeter. So with the help of these two meters, V and I can be measured. And then the graph can be plotted. Okay? So when you plot the graph, by keeping V on the y-axis, I on the x-axis, then Ohm's law suggests that you should get a straight line. Okay? So if you get a straight line, that means Ohm's law is verified. And this is exactly what will happen experimentally. Huh? Yeah. As you increase V, right? If you increase V, I will increase accordingly. Okay? So straight line. VI graph.
Think about your stuff.
It means Ohm's law is verified. Yes, I know. So I was just doing a recap so that.
Everyone recall this.
बैठना है क्लास में
Yes, I'm sorry.
चुपचाप बैठ.
Sir, I was speaking for you.
Don't do that. Let me do my job. You do yours. Okay? Be nice, otherwise I'll send you out. All right. So now let us start with the numerical. Everybody be silent. I am warning again and again. Be silent. So what does the slope of Ohm's law give? What is the slope of Ohm's law? Resistance. So slope of VI graph gives V2 minus V1 divided by I2 minus I1. So you can choose any 2 points. Let us say I choose these 2 points. So this will be V2, this will be V1, and this will be corresponding current. Why so much noise? Maintain absolute silence. So slope of VI graph is this. That is resistance. Because ratio of V by I is nothing but R. And this must be constant. Because for a straight line, you will get a constant slope. Is that clear? You're a new admission? Is this your first physics class? Okay. So you have to put up with it, okay? Alright, so far you have understood that the slope of VI graph gives resistance. So now a question for you.
Yes, sir.
So this is a graph shown for 2 conductors A and B. Which has higher resistance? A? Why?
Because
Yeah, what are you saying?
sir,
A is correct. Why?
yes, sir. So that is yes. A so bro.
What is resistance? Slope of VI graph. Slope is more for A. It is more steeper, right?
Yes.
So its slope is higher. Understood? Why the resistance of A is bigger? Because its slope is bigger. And slope is nothing but slope of VI graph is resistance. Okay? So these kind of questions might come. Okay, now open your volume page number 90. Do example 11.3. 90. 11.3. Do this. Read and do. 11.3. So what is given in the question?
How much current will
What is given here? Potential difference between the terminals.
60 V.
आगे बढ़ो, discuss. Page number 90. 90. Sorry, reading what is given in this? V is equal to 60 volts. When it draws a current law, what current will the heater draw if the potential difference is increased to 20? So how will you do it?
So sorry.
What is the given data?
The potential difference is
So when 60 volt is applied across the heater, the current drawn is 4 ampere. Now the question is, if the potential difference is doubled,
we already found the value of R, so we can use I is equals to V upon R.
correct. So you have to find the resistance and then use the Ohm's law. So, or directly from Ohm's law, right?
R is equals to
V is doubled, so current should be doubled. Logically, you should get here, right? But how will you solve? Since R is equal to V1 by I1. So what is this? 60 by 4. 15. Now in the second case, heater is not changing. So its resistance also will not change. So for the second case, therefore V2 is equal to RI2. This will be 15. So we have to find I2, right? Therefore I2 is equal to V2 by R. This is 15. So how much this will be?
so 8 amperes.
This is 8. All right. So next we will study resistance in detail. So what is resistance? What did I tell you resistance is?
V upon
No, what is resistance? What does it mean? Resist करता मतलब? Yes. It opposes or obstructs the flow of current. Yeah. It obstructs. This was a repetition which we have already done. This I can erase, right? This diagram I can erase. Diagram. This I have already told you. What is resistance? Obstruction to the flow of current. This is the next topic here.
Sir, he's calling.
About what? Okay. Yo. It is the measure of obstruction to the flow of current. This we already know. Okay? It is the measure of obstruction to the flow of current. This we already know. Either obstruction or you can say opposition. It offers opposition to the flow of current. What is its unit? We just wrote here. Its unit is ohms. This is the symbol. Unit of resistance is ohm, and this is how it is written. Now we will study what are the factors that affect resistance. Factors that affect resistance. Okay. So factors that resistance are the length of the wire. First is the length of the wire. How length of the wire affects resistance? If the length is increased, resistance also increases. So R is directly proportional to L. Okay, so if length increases, resistance of conductor also increases. Okay, next is,
Temperature.
we'll come to it. The area of cross section of wire. So what is the area of cross section of wire? The thickness. Let us say this is a piece of wire. So this is the area. Okay, circular area of cross section. So when will resistance increase? What is resistance because of? What is resistance because of? Collision of electron with the stationary ions, right? The conductor has combination of positive stationary ions and the electrons moving through it, right? So whenever electron moves through it, it collides the stationary positive ions. That is what causes resistance. And due to collision, heat is produced. So whenever current flows through the wire, it becomes hot due to the collisions. Okay. So if the length is doubled now, so initially collisions were happening only this much length. Now collision will happen till here. So is the resistance increasing or no? It will increase because now the collisions are also doubled. Okay. That is why with length resistance increases. Now, what if the wire thickness is doubled like this?
Then also it will increase, right?
Why?
Because the area is increasing, so more collision.
So it's like if I'm walking through this passage, right? So right now it is narrow. If I double the width,
Okay,
what
there
happens?
will be more space for the
Exactly.
electrons.
So now there is
the
more
less
space for
resistance.
electron to flow.
Less
So less resistance. So in this case, resistance is inversely proportional to area of cross section. This is how it varies. So when area of cross section increases, resistance of the wire decreases. So with increase in area of cross section, R decreases. Okay, so there is an inverse relation between area of the wire and resistance.
So that is 1/8.
1/8. Inversely proportional to area, no? Inverse relation. Okay. And obviously, when you increase the temperature, the number of collisions will further increase. So resistance also increases with temperature. Third is so resistance also increases with the temperature of the wire. See what happens if I increase the temperature. So the positive stationary ions which are there, it will start vibrating. So electron which was trying to flow, now the obstruction will increase due to the temperature. The positive ions are vibrating vigorously. With low temperature, they are vibrating but gentle vibration. With rising temperature, they vibrate vigorously. So imagine I am walking through here, and initially 1 or 2 kids were crossing. Now so many kids are crossing. So it will be difficult for me to walk. Understood? Understood? Like if somebody comes close and goes away, and now it will obstruct my walking through the passage. Vis-a-vis when you were like crossing it less or still. Okay, so think of the effect of temperature on the positive ions in that way. But anyway, this is insignificant. We'll be covering these two. Okay, so we'll be covering these two. So now, when we combine these two, combining these two, so combining.
Seven explains third one.
1 and 2. Huh?
Seven explain.
Just understand that when the temperature rises, resistance increases. Number of collisions will increase because it's not a smooth passage for electron because the ions also are shaking now. So that's why. So combining 1 and 2, this and this, what we'll get? We get R is proportional to L by A. So now we have combined this and this proportionality together. So R is proportional to L by A. So remove the constant of proportionality, you get rho L by A. What is rho now? Rho is specific resistance or resistivity, where rho is called specific resistance or resistivity. So what is resistivity now? So write down clear. So resistivity for a given substance. Now we just discussed resistance of the material or substance changes with its dimension, length or area. Okay, if you change the length or area of cross section, the resistance will change. So even if you have a copper wire, same conductor, if you change the length or its area, its resistance will change. So resistance is not a characteristic constant for a given substance. But resistivity is. If it is a constant substance, let us say if it is copper, so whether its length is 1, 2 times, 3 times, okay, its resistivity is not going to change. That is fixed for a given material. Is that clear? That is why we are saying resistivity is characteristic constant for a given substance. As long as material does not change, like if it is copper wire, its resistivity is same. If it is aluminum wire, its resistivity is same, irrespective of its dimension, length or area. So we have removed the dependency on length and area over resistance. So this is constant of proportionality. Okay, what is rho? Constant of proportionality. So how do we define it? Look here. In this expression, if we make L is equal to 1 unit and A also has 1 unit, then resistivity becomes equal to resistance. Isn't it? L और A को 1 करेंगे तो क्या होगा? Rho will become equal to R. है ना? So what is the definition of it? Resistivity is defined as resistance of the conductor of unit length and unit cross sectional area. Okay. So that is so what is specific resistance or resistivity? Resistance of it's written on the board. What were you doing when I was you were what? ABCD? What is the point in writing when you don't understand? Understand and write. So what is resistivity? Read.
Resistivity is defined as resistance of a conductor of unit length and unit cross-sectional area.
So if this is the expression for resistivity, if I put this as 1 and A as 1, then resistivity becomes resistance. Same thing I have written in English. Resistivity is resistance of conductor of unit length and unit cross-sectional area. Clear? So just this mathematical expression is written in English only. Okay? Is it clear? So we are now fixing the dimensions. Resistivity is always the resistance of a conductor of unit length and unit cross-sectional area. That's all. Okay. So now you have a table given in your volume for resistivity of various substances. It's on page 92. So the materials or substances are classified as conductors, alloys, and insulator. Right? So look at the values of resistivity for conductor and compare its value with insulator's value. Which value is higher?
Insulator's value is higher.
Much higher, right? How many times?
2 times approximately.
2 times.
Close to 2 times.
If you take silver, it is 10 raised to minus 8. If you take glass, it is 10 raised to 14. When you take the ratio, it will be 10 raised to 14 divided by 10 raised to minus 8, which is 10 raised to 22 times higher. What is the comparison? Take the ratio.
Yes.
So the insulator's resistance is higher by conductor's resistance by 10 raised to 22 times. So it is much higher. So no current can flow through insulator. No current can flow through insulator. That's why every wire is wrapped with an insulator, so that there is a live current going through the wire. But when you touch the wire, you don't get a shock because it is covered by a insulator. Understood? So this is the meaning of it. Now look at alloys. What is its resistivity? Is it higher than conductors? Is the resistivity of alloy higher than conductor? At least 100 times higher, minimum 100 times. So 4900 times higher, constant 10. So what is constant 10? It is alloy of copper and nickel. Just see what is the individual resistivity of copper. 10 raised to minus 8. And what is nickel? 6.8 into 10 raised to minus 8. But when they are mixed and made alloy, then their resistivity drastically increases. So as an individual metals, the resistivity is less. but as alloy, the resistivity is much higher. Okay, so they find certain applications. We make use of alloys to make resistances, which are then used in electrical circuits. Okay, so all those resistors that are drawn, okay, that will be made up of alloys. Clear? So why do we need resistance in electrical circuits? To regulate current. We have to restrict current, right? Otherwise, like this fan, do I want to always run it at full speed? No. So I have 5 speeds. So therefore, there are 5 different resistances connected here. So at the lowest resistance, it will run at full speed. When I increase the resistance, the speed will reduce. Understood? So you require various types of resistances to control the flow of current in the circuit. Okay? Is that clear? So have you written everything on the board? Okay, let's take up numericals.
Second is off.
Go. Why can't you wait in a class of 2 hours?
Sorry.
Avoid going to washroom during the class. I mean, you're no more kids. You can hold it. Is there any patient here who can't? I mean, the bladder is so weak that you can't hold the urine. Huh? You have to write exam which runs for 3 hours, and you're not allowed to go there. पता है कि नहीं? फिर से पूछ रहा हूँ. हमेशा भागते रहते हैं. Build that habit to hold all these things. Okay? Okay, let's proceed now. So is the table understood? Okay, let's go back and do the numerical. So we are now going to do numerical number 11.5. So one question. Will resistivity of a material increase if I change its length? तो खाली देखने के लिए आता है. इधर देखो, अगर मैं किसी इस सब्सटेंस का लेंथ डबल कर दूं तो उसका रेजिस्टिविटी चेंज होगा क्या? रेजिस्टिविटी चेंज होगा कि रेजिस्टेंस चेंज होगा? Resistivity is a characteristic constant for a given substance. अगर एक मटेरियल है तो उसका कुछ भी रेजिस्टेंस चेंज होगा. समझ में आया? ये अभी तक जो पढ़ा है उसका मतलब ये है कि रेजिस्टिविटी चेंज नहीं होगा. अभी अगर मैं इसका एरिया चेंज कर दूं तो रेजिस्टिविटी चेंज होगा? नहीं. अगर मैं कॉपर वायर को एल्यूमिनियम वायर से रिप्लेस कर दूं, कॉपर वायर की जगह मैंने एल्यूमिनियम वायर ले लिया, अब रेजिस्टिविटी चेंज होगा? कॉपर वायर की बजाय अभी मैंने एल्यूमिनियम वायर लिया तो चेंज होगा? होगा, क्योंकि सब्सटेंस चेंज होगी. ठीक है? जैसे ही सब्सटेंस चेंज होगा तो रेजिस्टिविटी चेंज होगा, डायमेंशन से चेंज नहीं होगा. ये चीज दिमाग में रखो. नाउ लेट्स डू एग्जांपल 11.5. इट इज ऑन पेज 91. So what is given here? A wire of given material having length L and area of cross section A has a resistance of 4 ohm. So suppose you have a wire of length L. This is L and its area of cross section is A. For this, resistance is given as 4 ohm. Now, what would be the resistance of another wire of the same material having the length half and area of cross section double? So now we have another wire whose length is half and area of cross section is now double. So now you have half of the length. You have to find R dash is equal to what? What is the new resistance? That's what you have to find. So what will happen? Is the material changed?
No.
So what about resistivity?
Resistivity will remain constant.
So resistivity, let us assume resistivity is rho. It will remain same
Yes.
for both cases. So what is R? So what will be R dash now? R dash will be equal to rho times L by 2 divided by 2A. Isn't it? R dash will be this. What is R dash? What is the relation between resistance, resistivity, length and area? So from this equation, R dash will be equal to rho times length of this wire divided by 2A. And this is L by 2 into 2. So it will become 1 by 4 times L by A. But what is rho L by A? Rho L by A is R. So whenever you reduce the length of the wire by half and double its area, then what happens to its resistance? It becomes 1/4. Look here. Right. Where R is equal to. This R. What is this R? Rho L by A, which is nothing but 4. This is given in the question. Understood now? When you simplify this, L by 2, 2 will come in denominator, already 1, 2. So 2 into 2, 4, that comes out. So in bracket you have rho L by A. This is nothing but this R. Clear? Okay, next question you try now. Next question is 11 point. What we did was 11.5. Now 11.6. So somebody read example 11.6.
Resistance of a metal wire of length 1 meter is 26.
Oh.
Sorry. And 20 degrees Celsius. The diameter of a wire is 0.3 millimeter. What will the resistivity of the metal at that temperature? Using the table which referred above, predict the material of the wire.
So first you find the resistivity from the given data. Then you find from the table, it is the resistivity of which substance. Okay? Find out. So what is given here? So length is given. L of the wire is 1 meter. R given is 26 ohm. diameter of the wire is 0.3 millimeter. Then you have to find out resistivity of the wire. So how will you find it from the given data?
Resistivity would be R into A upon L.
Yes, very good. So solution. So since R is equal to rho L by A, this gives us
R A upon L is equals to
R A upon.
R A upon L.
Yes. Now, are you provided with area? No, you are provided with diameter of the wire. So what is area?
Pi R square. Pi D upon 2.
Yes. Pi R square, which is equal to pi d by 2 whole square. So you have to substitute this area over here. Therefore, rho is equal to R by L into pi d by 2 whole square. Now substitute the values and solve. So what will be unit of resistivity? Unit of resistivity will be ohm meter square per meter. Ohm meter. Ohm meter.
Meter square.
This meter. Okay. So find out. So R 26 divided by 1 into 3.14 into. How much is D?
Is it 22 by
D will be
7?
0.3 into 10 raised to minus 3 meter, which is 3 into 10 raised to minus 4 meter. So this is 3 into 10 raised to minus 4 upon 2 whole square. This is 26. Divided by 4. So this is 2 times 1, 3 times. So now you multiply this 40 into 1.07 and this to minus. So when you solve this, you will get
0. So this is calculation.
1.84 into 10 raised to minus 6. This is what you will get ohm meter.
So this is the resistance of manganese.
Yes. So you can see in the table that this value corresponds to manganese. GA manganese. So everyone understood how we did this? So basically here area is not given directly. It is given in terms of diameter of the wire. So from diameter you calculate area. Radius is half of diameter. So square of that times pi. This is how you do it. Is that clear? What conference going on?
Can't we do the conversion of millimeters into meters without the like raised to minus 3 minus
Sir?
4?
How can you do? You can do divide by 1000.
Yeah.
So what is it? 10 is minus 3.
I was asking what is this?
Manganese.
Done.
Okay. So the next topic is combination of resistances. Let's now learn combination of resistances. So first is series combination. First we are going to learn about combination in series. So let us say we have three resistors. There are three resistors R1, R2 and R3. So we have combined, whenever resistors are connected like this, it is called series combination. Okay. Now we want to connect voltmeter across each resistor to measure what is the voltage across R1 and R2. So what have we done? We have connected 3 voltmeters to measure voltage across R1, R2 and R3. And in series connection, current will be same. What is the path of flow of current? It's only single path. Got it? In series circuit, current through all the three resistances will be same. So let's call this V1, V2 and V3. Now, will the same work be done in moving a charge across all the three resistors? Same work will be done? Or different work will be done?
If it is different, so it will be
If it is
different. If the setting is different, the resistance is different, so it's
correct. If the resistance is different, then the work done in moving the charge will be different. Because different opposition. Charge is moved against different opposition. So cell will do different work in different resistors. That's why you have V1, V2, V3. Because what is V1, V2, V3? It is potential difference, which is work done per unit charge. So the work done will be different in different resistors. That's why V1, V2, V3 will be different. Okay? But what about current? Current is flowing like this. So same current flows through the all three resistors. Current is same, but potential difference is divided. So write down in series circuit, in series combination. In series combination, the current remains same through different resistors. But the potential potential difference. So what is the potential difference of the cell? Cell potential difference is V. So V is the total potential difference of the cell, and now it is distributed across different resistors. Okay. It is distributed. Across. Okay. Same potential difference applied is पढ़ रहा है लिखने की बात बोल पढ़ो ये बात को ले बाहर करते हो ये मैं मार भी हूँ मैं चुपचाप बैठ बोल रहा है वैसा बोल दो मैं देख रहा हूँ तू क्या कर रहा है चुपचाप बैठ और बैठना है जो पढ़ाई करनी है या बकवास करना है तो चुपचाप बैठेगा तो कुछ नहीं बोलेगा चलो आगे देखो तीनों को बाहर कर दूंगा मैं अगर फिजिक्स के अलावा कोई बात किया तो बाहर ठीक है तो क्या बोला मैंने पोटेंशियल डिफरेंस अप्लाइड क्या हो रहा है वहां पे पोटेंशियल कितना अप्लाई किया सेल में V ठीक है वो V का क्या हो रहा है V is actually making the charges move through the circuit. All the charges are flowing, they are flowing through R1, R2 and R3. But the work done will be different because different opposition is forced by different resistors. Okay? So what is V then totally? Therefore V is equal to V1 plus V2 plus V3. मैं अभी भी बोल रहा हूँ चुपचाप बैठो निकाल दूंगा मैं कंटिन्यूस आवाज आ रही है वहां से बुलाओ शरद को so this applied potential difference is distributed across the resistors as V1, V2 and V3 so this will add up. So what are we supposed to find in the combination now? We are supposed to find the equivalent resistance of this combination. What is the equivalent resistor of this combination? देखो, equivalent resistor of this combination will be, let us say, the equivalent resistance of this combination is RS. क्या हो गया ये देखो this resistance effect is such that the same current is flowing now. What did I say? The combination of this resistance is such that the same current is still flowing through the circuit. I. Okay, so what will be V by Ohm's law? So by Ohm's law, if the potential difference applied across the RS is V, okay, let us say we measure the potential difference. So same V will now appear across R only. There is only one resistance, so now it will be V. So V will be IRS. Now we are applying Ohm's law. So what is V? This will be equal to I times RS. What about V1? I times R1. What is V2? I times R2. Plain application of Ohm's law. Okay. So now what do you have? IR1 plus IR2 plus IR3. So I gets cancelled. Therefore, RS is equal to
R1 plus R2 plus R3. So how is I getting answered?
same I know in both the circuits.
Okay.
Because this is the equivalent of series combination of these resistors. So nothing is changing in the circuit. V and I remain same. Now we have equivalent combination. So it will be IRS. That's all. Okay. So in the series combination, the resistances just get added. Now let us see what happens in parallel combination. So what is RS? Where RS is? Where RS is equivalent what you did not understand. If I replace all these three resistances with one resistor, RS, it is the equivalent of series combination of this. Because now the current is not changing, current is same. That means now this one resistance is giving the opposition, which three resistance together were giving in series. Is that clear? So that is what it is. So what is that combination? What is that equivalent resistance of all these three resistors in series? RS, which is plain addition of this. Okay. Now we are going to study about parallel combination. Sometimes the question might come on derivation. Derive the relation for equivalent series resistance. Okay, then this is how you derive. Derive the expression for equivalent parallel combination. Okay, that is, we do it in the next class.
Sorry. अरे प्लीज नहीं
अरे साइड रखना, नाइसा तो छोटी सी धक्का मार के जाओ उसको। अरे कितना गधा है यार। कैच भी को लगता है तो मैं अरे चल
Thank you.